Hey, hi Edward. I'm good. How are you doing? I'm good. How are you doing? Oh, okay. I'm good. How are you doing? Oh, okay. Okay. Oh, okay. 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 Sure. So on Twitch, I can just like if people have questions, I can just put it on the chat, right? So like I can reply on the chat and stuff.
Hello everyone. Hello everyone. I'm glad to start and to kick off the. Hello everyone. Hello everyone. Yeah. I'm glad to start and to kick off the. The song was still on the live was when I was checking. No, it's better. Sorry about that little sound trick. Uh, yeah, I'm super excited to kick off that hackathon. I can see as well on the take guide some of you already started submitting your projects and starting the hacking as well. I'm really glad to start and to kick off that first workshop with you, Gnana. Gnana, am I correcting that correctly? Gnana, sorry, yeah, perfect. Okay, just checking as well with the chat if the sound is great for you, or do you need a bit more sound, or just tell if it's okay. Say super if it's good, or higher if it's too loud, or lower if it's too loud, or yeah, up, yeah.
How about my sound? Is it good?
On my end, your sound is perfect. I can see as well here on my terminal of the streaming that people should hear you clearly as well. But like, if at some point the sound is not correct or not good for you, just tell me as well in the chat, and I will figure that out. I will change that and change the setting. Okay, thanks a lot. And then yeah, I think that we can already kick off with the first workshop. This workshop is of course recorded, and then it will be like uploaded on this Twitch account and also on our YouTube account. This first workshops is about account abstraction. I think like everybody is excited as well to learn more because that's a great and one of the major as well competitive advantage in futures of Starknet compared to Ethereum or other L2. So yeah, thanks Anna, and now I give you the stage.
Awesome. Thank you so much, Edward. And I've tried to create like as much of a noise-free environment as possible. But you must understand that I'm based in India and there's always something happening somewhere. So there's going to be some background noise, but I've switched on my noise cancellation app. So I hope it's all good. I'm going to try and share my screen now. And I want to know if it's all good. Is everyone okay? I'm gonna take off this chat button for here. Okay, awesome. Mm, is everyone able to see my screen? Edward, are you able to see my screen? Okay, perfect. Perfect. So, first of all, full disclosure, this entire set of slides has been created by my colleague Yael for one of her recent talks. And I just told her that, hey, can you lend me your slides? I'm going to mix and match with a couple of other concepts that I am familiar with and then trying to put together for the workshop. I know that large parts of this workshop will be coding, looking at code, trying to build our contracts, etc. But I've created these slides so there is a bit of context in terms of what are smart contract accounts, or as the slide says, native smart accounts on Stucknet, right? There is a lot of buzz around smart contract wallets, smart contract accounts. Recently at ETH Denver, the Ethereum team announced EIP 4337, which is an interesting proposal to add, smart contract accounts. It's been there for a while, even in the Ethereum ecosystem, but now it is getting a lot of traction, largely because of a huge problem that it is solving, which is blockchain UX, right? The user experience of using applications in the Web3 space has been extremely bad. And we haven't had so many users largely because of this problem, right? That how do we make the user experience smooth? And smart contract accounts seems to be like one of the answers or one of the steps in the right direction to do this. So today we will talk about that, the smart contract accounts, little bit about the architecture and how it works, and then we will code a very simple smart contract where we will code this live, and then I will also share some other code pieces with you that you can use to actually build your applications for the hackathon, if you are going to be using the idea of smart contract accounts. And of course I highly encourage it. My name is Gnana Lakshmi. I'm based in Bangalore, India. I work as a developer advocate with the Starkware team, and you can find me on Twitter at GYANLAKSHMI. So before I dive into the theory part of it, what I want to do is, so everybody set up for success during the workshop, I want you to do some of these prerequisites, which is install Rust if you don't have Rust on your system. And then you would have to install something called Scarb. So Scarb is a tool that you use to basically write and build contracts. So for example, let me just add a link. So here you go. So you can follow these instructions to install Scarb. I'm posting it on the Pragma Oracle, the live stream as well. And then if you don't have Rust, you can also install Rust. So if you have all of these installations ready, then it will be much easier for you to follow along during the workshop, because the coding part of the workshop is actually quite simple. Let me post this as well. Yeah. And you can just put this for installation and we can continue with the talk. Because it's going to take a while. I want you to get this up and running. And once we reach the stage of programming, then we will do all of these steps together. So let's get started. So today we will talk about Starknet native smart contracts. And one of the reasons that I said why these are becoming very popular is because people are largely scared of blockchain. It's because they are scared of exploring new technology, right? And as early adopters of this technology, as early users of this technology, it is important for us to make this problem go away, or to make this path easy for new people to get onboarded to blockchain. Why are people scared of blockchain? Because they don't understand it. They don't understand how it works. They feel like it is technically complex. And then there is a lot of work that is required just to be a user in the ecosystem, right? We know all of the pain points, like, having to remember seed phrases, having different wallets for different things, etc., etc. So in today's agenda, I'm going to cover account abstraction basics, which is going to be a large part of the agenda. Of course, it's a game changer. And then we'll not just talk about one, but two different implementations very quickly. That is EIP 4337 and Starknet native smart contract. And then I'm going to skip the last part. We are just going to do the coding. So what is account abstraction? If you're already familiar with the Ethereum ecosystem, which I'm assuming most of you are because you've joined the Cairo 1 hackathon, Starknet is a layer 2 which supports, which is largely built to scale Ethereum, which is the layer 1. The concept of Ethereum is, and the transactions and accounts concept of Ethereum is largely based on the idea of externally owned accounts. That is, every user who has to interact with the Ethereum blockchain should have an externally owned account. An externally owned account is the only account that can initiate transactions on the Ethereum blockchain, right? It could be right now with EIP 4337, we can deploy smart contract wallets, but you would still need the first transaction for those smart contract wallets to be initiated by an externally owned account. Now, what are externally owned accounts? Externally owned accounts are created by creating a public-private key pair. It's largely controlled by a private key, right? You can see this private key in different forms. In the form of the largely popular one is a mnemonic, where you have 12 words, 16 words, seed phrases, etc., that you need to remember, and that acts as your private password to access the account. It can send transactions. Externally owned account are largely used for sending transactions. For example, if Alice has to transfer X amount of funds from account A to account B, she has to trigger a transaction from her externally owned account, say account A, which belongs to Alice. Whereas smart contract accounts can be more general in the logic phase. For example, you could build a smart contract account that could be natively multi-sig. You could build a smart contract account that could natively incorporate social recovery. That means maybe you distribute the keys between your friends and then you are eventually able to recover your account without having to actually remember your private key altogether. But in this case, smart contract accounts cannot initiate transactions, right, on Ethereum. So because of this, the user experience with externally owned accounts is very, like I said, it is quite horrible. You have to remember things like seed phrases. And then, if something breaks, then you really can't, where do you hide the money, right? However, account abstraction gives you the ability to sort of break out of this, and then gives you some more added advantages apart from what we already think it could be, which is improving the UX, which is improving the experience, right? That users don't have to remember seed phrases. Users don't have to think about, storing their JSON files or whatever. Users don't even have to think about what is a JSON for that matter, right? So what does account abstraction provide? When account abstraction, if you use account abstraction, you can use different signature schemes. So for example, right now Ethereum uses ECDSA, right, which is elliptic curve digital signature algorithm, which is a popular signature scheme. But as we are looking at the advancements in quantum computing, which can potentially break cryptographic algorithms, you want to also mix and match different signature schemes that could give you an advantage that could be better than the existing cryptographic signature schemes that are there. Another biggest problem when it comes to the bad user experience is the fact that on Ethereum, when you're transacting, you have to always pay gas fees with ETH, which is going to be the case even when EIP 4337 is implemented on Ethereum. But internally, you can add features like pay masters, etc. And for the user, they can pay fees with a different token. So basically, imagine that you want to just transact and you have like any random coins in your wallet. You could just use those to, do your transactions, pay your gas fees. You can atomically enable multi-call. That means you can send batch transactions. You can have multiple calls happening at the same time. And this is very, very essential. So you can also optimize on gas, right? And get multiple things done at the same time. A simple example of a multi-call is when you're trying to swap on Uniswap, right? You have to say you're getting introduced to a new currency that you want to swap. So you will have to add that, you will have to approve that, and then you will have to then perform the swap, right? You will have to approve the ERC20, that this particular ERC20 can be swapped, and then you will have to perform a swap operation. However, in multi-call, you can have both of these calls happening one by one and together, and the user has to only perform one signature. So you can enable atomic multi-call in account abstraction. uh, you can do different types of prevention mechanisms for replay attacks, like a common example of replay. One of the What is a replay attack? Basically, when a hacker tries to kind of listens to a message that is being sent, and they try to attack the network by replaying the same kind of message, so that the receiver believes the hacker and kind of sends funds or whatever. So this is your generic on a network level how the replay attack works. But you have different things right now to prevent the replay attack. One of them is sending sequential nonce. So you might have seen, while you are for every account there is a sequential nonce, that is the nonce number keeps incrementing as you keep performing different transactions. This is to prevent replay attack, that the same kind of transaction is not sent by somebody else, right? But you can also add different types of prevention schemes because you are designing the account right now, right? And of course the whole general logic itself can be moved around. So this is an experience game changer in itself, where the user experience can be more Web 2 like. You can have more design elements, more interactive elements, instead of users having to just, right now, the crypto environment is more like users have to create an account, they get a wallet address, which is a really long hexadecimal string, and then they get a 12-word seed, 12 or 16-word seed phrase, etc. However, here you can mimic more of a Web2 user experience by adding interesting things like social recovery and all of that. And then you can also have enable multi-sig, which is multi-signer by default at the very atomic level. That is, the account that you're going to deploy in itself will have multiple people who will be signing the transaction instead of one person doing it. Fraud detection. So you can easily understand, you can add more mechanisms into your account in terms of how fraud detection can be done. So for example, you can, before the transaction is actually executed, and I will show you the workflow of how it is validated, executed, etc. But before it is executed, you can send the transaction to a server which is trying to break down the transaction and understand if there is any fraudulent activity in that transaction. And at that place itself, you can break the transaction and say that this is invalid before even it gets executed. So basically, you can design such kind of mechanisms when you're designing your own account. And for session keys, so this is a huge problem for the gaming ecosystem, that if you are in a Web3 based game, then you have to constantly keep signing the session key once your session time runs out. So you'll have to again say that to verify that yes, you are the same person who's logged in with a specific public key, you have to also put a stamp using your signature, etc. So you can delegate this task to someone else for some time and then just enjoy your game, for a while. So better UX is going to lead to wider adoption. So I suggest everyone who's thinking about building some cool ideas for the hackathon to think about implementing account abstraction in your idea, or you can just build something which is like a multi-sig wallet using account abstraction itself. That's a cool idea. You can have an account which is natively supporting multi calls. So we will see that in our hands-on session, and then you can sort of also build that out for your pragma oracle account. Okay, so what are the different account abstraction solutions? So like we said, not just one, we'll be talking about two solutions. That's because EIP 4337 kind of forms the base of everything account abstraction that was started early on. And we also talk about what are some of the issues that, one of the main issues that could potentially arise in EIP 4337, and how Starknet native accounts, mitigate that. So what are the EIP 4337 goals? The first is to allow users to use smart contract wallets, right? So you allow users to avoid having an externally owned account. That means they will not have to manage the keys, they will not have to manage the seed phrase, etc. And to bring about more decentralization, right? So this allows more and more people to kind of come into the ecosystem, and there are not set of huge wallets that are controlling the ecosystem and things like that. So there is no central entity in the protocol. And account abstraction users will get the same guarantees as the EOA users, of course. That's the idea with decentralization, right? And you don't make any changes to the Ethereum consensus layer. So this is a very important thing on how EIP 4337 functions, is that you don't make any changes to the Ethereum consensus layer. Rather, you try to do things at the application layer. So how does it work? All of the operations that are performed by the users. So as a user, you would do multiple things on the Ethereum blockchain. You would initiate transfers. You would want to call some smart contracts. You would want to perform some swaps and all of these operations, right? So there is a separate mempool for this, which is called the user operation mempool. And the user operations are sent to the user operations mempool. From there is an entity called the bundler. So bundler is not exactly a validator, but you can think of the bundler as doing some computation, some sort of computation operation on this user operation mempool. So it collects these user operations, puts them together, right, bundles them, and then sends them to a unique contract called the entry point contract. So there are several entry point contracts that have been published as of date, and the bundlers would need to whitelist the entry point contracts that they would like to use. Now, from the entry point contract, for each of the user operations, there are two things that will happen. The first is validating the operation, whether this operation is correct or not. And then the second one is obviously executing the operation. So if you want to get more idea about how this works, I also suggest taking a look at the ERC 4337, which is the account of abstraction using alt mempool. So the word alt mempool, because there is a separate mempool where these user operation transactions will go. There are some solidity contracts that are there as examples. And this is pretty much the same workflow that we spoke about, that we call the account with the user operations call data. Then it basically goes to the bundler. From the bundler, it goes to the entry point contract. You verify, and then verify and pay, and then execute and refund if there is anything extra that is there from the gas. I will also talk about the extension quite just after, probably in 1 or 2 slides. Oh, the next slide itself. So this is a simple overview of how you can implement a simple account smart contract on Ethereum, right? Now, another feature that we spoke about account contracts and why they could be significant is that they can have another, like you can pay the gas fees in another token, right? Not just Ethereum. So for this, there is a structure called the paymaster. What is a paymaster? A paymaster is a service provider which deploys a contract on Ethereum. It makes sure that it has funds, and then this paymaster pays the fees in ETH on behalf of the user. So, like I said, for the actual transaction, the fees are still being paid in ETH, but the conversion of this, whatever the user is giving the token to ETH, is being taken care of by the paymaster. So ideally, what happens is a user initiates a transaction, then the paymaster pays the transaction fee in ETH. And for example, if the user is initiating transaction USDC, the paymaster gets back USDC. Now, what could be the problems in this? So, what could be one of the common problems in this particular architecture is the DOS attack on the bundler. So, on the bundler, there could be a denial of service attack by the user or by the paymaster. So, for example, when a bundler can simulate the validate function, and if the simulation is passed, it inserts it into the mempool. Now, the operation is inserted into a block, right? Because you have simulated the validation function and a simulation is passed. But at the real-time validation actually fails, right? Only the simulated validation passes. But the bundler has already done some work. That's why I told that bundler is not exactly a validator, but it does some compute, right, to simulate the validation. But the real-time validation actually fails. And now in this case, because it's a failed transaction, bundler is not getting paid. And this can, this happens repetitively to the bundler, then there is a problem, right? So this is one of the attacks. And some of the solutions, or rather the solution that we think is going to help is having native smart contract accounts on layer 2s like Starknet. So Starknet has a native smart contract account. What that means is on Starknet, there is no concept of externally owned accounts. All the accounts by default are smart contract accounts. So every account in itself is a contract, and there is no concept of externally owned accounts. And because of this, you can have flexible fields for the signature, and you can have the sender address will always be the account contract address. So what happens in a life cycle is that whenever you create a new account on Starknet, it basically creates a contract account for you. And there are different ways you can fund the contract account to become active. But one of the ways right now that we do using OpenZeppelin account is you create a public key, you fund that account, and then you deploy that account as a smart contract account on Starknet using the funds that you have already added to that account. So it's like a self deployment. But there are multiple ways you can deploy a smart contract account. You can use an existing account to deploy an account contract and then start using that whenever you would want. So here in this case, the sender address will always be the account contract address because there is no EOA. And I'll show you the functions also with the contract structure. But there are two main functions in the account contract structure. One is validate, which verifies the account signature, right? Now here within your contract, you can try to, add different types of signature. So as you write the account, you can validate any type of signature, right? And the second is execute. Once the validation is successful, you can execute this particular call or particular function that has come to you, and you can call that function to execute it. And this can also be a multi-call, as you will see shortly. So this is a very overwhelming sort of diagram, and huge credits to the Devrel at Argent Darlington, who also did an account abstraction workshop with us, for creating this beautiful sort of structure. So what happens when how do transactions actually take place on the account contract, right? So in the Starknet architecture, we have the sequencer, which is responsible for creating the blocks on L2, right? And then the execution trace is sent to the sharp prover, and then the sharp actually sends the proof to the validity proofs to the verifier, which is on Ethereum. It verifies the proofs and then, adds it to the fact registry and all of that. So in this case, we have the sequencer. And when the transactions come to the sequencer, it picks the transactions for batch. And then once it is finished with the picked transactions, right, it will it will pick the transaction and then it will validate the nonce, right? If the nonce is invalid, it rejects the transaction. If the nonce is valid, then it goes to the account contract. Within the account contract, you have the function to validate the transaction, right? Once the transaction is valid, you pay for the transaction and then you execute the transaction, which is also at the account contract level. So the sequencer is the element which is basically making the calls to the account contract to validate the transaction and then execute the transaction. So if the transactions are successful, the execution is successful, you add the transactions and the output to the batch. So what are some of the things we see, like, versus EIP 4337 versus native smart contract accounts on Starknet, right? So fee abstraction, nonce abstraction, all of these are going to come in the future version. Signature abstraction, yes. Bundler support, there is nothing needed because you just deploy the account contract and then you have the validate and the execute there, which is what it is doing. And from the financial risk, there is no financial risk on native smart accounts. However, in the EIP 4337 case, bundlers are taking the risk, right, of coming into the DDoS play. DOS play. Legacy EOS. So there is no concept of EOS. So only smart contract accounts on Starknet. And however, EIP 4337 right now needs to support both account types because there is no change at the protocol layer. L1 account abstraction is costly. Why? Because you have to deploy an account contract and you will have to pay like a bomb on it, bomb for it on Ethereum. However, on Starknet, because the cost is very less, because it's an L2 and it works on the concept of validity proofs, etc. All of this you're familiar with. The cost is less, so there is almost 100x reduction in the amount that is required to deploy a smart contract. So quick summary, you can use different signature schemes. You can have multi-signer, which is better security. You can have mobile signer with better UX. And there are also a lot of other cool features like fraud detection, session keys, recurring payments, and a lot of other ideas that you can build on top of this. There are real-world applications with things like smart contract wallets or wallets, wallet applications like Bravos and Argent, which are available on Starknet. You can check them out if you haven't done so yet. And then Visa is also, slowly using this account abstraction. And then you have improved experience, which will lead to larger adoption, right? So definitely you should try this on Starknet. And now let's code. Okay. So the first thing, like I mentioned, that I would want you to do is to install Rust and Scar. And for those of you who are going to be coding along with me today, can I get a show of hands, or sort of like, can I get an idea of how many of you are through the installation? Do you need some time, or how is it right now? Can I get like some emoji on the chat if you are ready to go in terms of the coding bit of it? Okay, I'm also going to help you with the emoji that you can use. Let's say, what is this? Okay, party hat. Okay, send me a party hat if you are ready to party. I mean, code. I'm gonna stop presenting and I'm gonna present entire screen now. Okay. Let's see. Okay. How many of you are ready to code? Can I get some sort of smiley on the chat? Also, let me know if you're able to see my screen right now, like this Visual Studio Code editor, also my terminal. Uh, Edward, are you able to see my screen? Like, are you able to see the VS Code and my terminal?
Yeah, we are able to see your entire screen, and I can see as well that OX per friend is ready as well to code. If you want to as well interact in the chat, make sure to follow the channel and also create an account on Twitch, of course.
Okay. Perfect. So, for those of you who are able to chat right now and have sent me a party hat, thank you. And let's get started. I hope you have installed Scarb and Rust. For those of you who are watching this recording later on, I think you have more time, so don't worry about it. I've also sent a small gist, which is a link to a partially written code that I have written for the exercise. It's called AA underscore multi dot Cairo. There are a lot of TBDs in this particular contract, which is what we will be filling up as part of this live hands-on workshop because of the time constraints that we have. And then I'll also talk about the different functions, etc., that are part of the account contract itself. Okay, so let's go. So uh, before we get started, I'm going to show you how to work with Scarb. Okay, so I have a directory called Scarb where I put all of my Scarb projects. Of course, I already have a two folders for account abstraction. But to create a scar project is very, very simple. You can just write scar space new and then say the name of your project, right? So I want to say like account workshop or something. So I'm going to say this. Okay. So when you do scar new, it is automatically going to create a package for you. So you can see that account workshop package has been created for me. I can get into this account workshop package, and then you will see that there are two things. There is a folder called src, and there is a .toml file called scar.toml. So if you want to explore this a little bit more, you can open this up on VS Code, right? And then you can see what are the different components. So here is a scar.toml. Here the package gives you the name of the package that you have created, what is the version, and then what are, if you want to read more about the keys and the definitions, etc., you can go to the software mansion page and look at it. And then you can add the dependencies here based on what are the different things that you would like to do. So in order to compile so Cairo is a programming language, right? I got to know that you have already had a workshop or something on Starklinks. So I'm sure most of you are already familiar with Starklinks, or the content has been shared with you, one of these. So you would understand that Cairo is a programming language in which you can write code to create provable programs, right? So, because Cairo is a programming language that you can use even otherwise outside the context of Starknet, in order to tell the contract that this is a Starknet contract, you will have to add certain macros at the beginning of the contract. Now, let me also Ah, so there is a small dependency of the Starknet version that you would need to add in scar.toml to make sure that your contracts are also being able to build, right? That you're also able to build your contracts. So under dependencies, I'm going to add this, which is Starknet version, right? That this particular Scarb project should also support Starknet contracts, not just Cairo native code. So if you go inside source, you will see a file called lib.cairo, which has a simple Cairo program, right? And the step to build this is also quite, straightforward. So I'm inside this, I can say scar build, and this will just compile my particular program, which is the lib.cairo, and it will give me a Sierra code, right? So basically what happens when you compile a Cairo program is that it gets converted to an intermediate representation called Sierra, which we will see right now. Sorry. So within target, you can see that there is a file called acc_workshop.sierra. So Sierra is the safe intermediate representation, which is then eventually compiled to basically CASM, which is Cairo assembly, and then that is deployed on Starknet. So first your Cairo code is compiled to Sierra, which is then compiled to Cairo assembly, which is then deployed on Starknet. So most of the times you don't have to do this two-step compilation. You can either use SCAR, you can use other tools like Protostar, or you can use the Starknet CLI to do the compilation. And using the Starknet CLI, you can directly compile to CASM as well. But it's good to know that, that this is how the Sierra code looks. You have a simple Fibonacci function, and this is how it compiles to Sierra, right? So it is more close to like assembly level. You can see there are things like drop, duplicate, add, constant, subtract, then it stores temporarily. There is a enum match, then there is, branching happening, then all sorts of different things happening here, right? So so for this exercise, you would need to create a folder called Scarb. You would need to create a project called Scarb, let's say account abstraction or whatever you would like to call it. And then within this, we will be working on our own file, which is the lib. One second. Okay. So this is my folder that I've already created, account abstraction. And within the account abstraction project, I have initially I had the lib.cairo. So I removed everything, deleted everything from lib.cairo, and I created a new file called multicall.cairo, which is where you can paste this gist code that I shared on the chat, and you can copy paste that entire code. It's not complete, so it will not build successfully, but we will complete it throughout this workshop, and then you should be able to build it as well. And in the lib.cairo, since the first step for this particular scarf file is to look at what is on lib.cairo, I'm just adding the multi-call module to the lib.cairo, so it will know that it is supposed to run this, right? Build this. Now on scarf.toml, in scarf.toml, I have added the Starknet dependency, so the contract itself can get compiled. Now I'm going to show you some components of an account contract. So this is a simple account contract. In a normal Cairo 1 contract, you would just remove this entire part and you would just add the macro hash contract. But because this is an account contract, you are adding the macro hash of account_contract. So this is the macro to actually tell that this is going to be an account contract. And then in Cairo, Cairo 1.0, you have all of the logic that you write is written inside or is wrapped inside something called as modules. So to start, so this is similar to your contract keyword in Solidity. So to start the contract, you say mod and then space the name of the account, right? Sorry, name of the contract. So in this case, the name of the contract is account. So this is similar to contract space name of the contract. So you have mod space name of the contract. And then within these two brackets is where your entire logic of what you want to do in this contract will exist. Now, in this case, we are looking at a particular contract, which is the account abstraction contract. So what are the different functions that an account abstraction contract on Starknet generally has? And like I said, this is not fixed in stone, right? You can take this syntax and you can add certain elements to it based on what kind of account do you want to build. Do you want to build a native multi-sig account? Do you want multi-call to be natively supported? Do you want to add some other signature schemes within your account contract? You can do whatever you want. But here, this is just like a skeletal version of what are some potential things that would be there as part of the contract. So the first thing that you would see is you would see a lot of required imports. What are the different imports that are required for this contract to function smoothly? And for that import, you have to use the keyword use. So use is like import, similar to the import keyword. And then you will choose the library from which you want to import and the functionality that you want to import. So here we are taking from the Starknet library the functionality of contract address, which is a type of variable that can hold contract addresses. And then we have constructors. So whenever you define a constructor, which is so you will use a function keyword called fn, and then constructor, which is going to be the constructor itself, like a function. And then you can define a constructor like this. You can also do some things within the constructor, like assigning the public key or whatever. But basically, this is how you declare a constructor. And to tell the compiler that this is a constructor, you need to add a macro called constructor on top. So all of these that you see on top of the functions are called macros. And macros as a general concept actually expand to more code that tell the compiler that this particular function has to behave in a certain way. So this macro tells that this function is a constructor, that it will be initialized at the beginning of the contract when the contract is deployed. And then we have another function, which is because it doesn't have any macro associated with it, this is just a simple internal function. So you have a function, the keyword for functions is fn, function name is valid signature, it does not take any arguments, and it returns an object of type felt252. So Cairo has a special object type called felt252, which is field elements. And this type is largely supported because Cairo supports proving Stark mathematics, right? Creating Stark proofs. So Stark proofs have a mathematical concept called field elements. And largely because they depend on field elements, this particular type of variable has been introduced natively called field elements. So here also you can see this is the type, this is the name of the variable, colon, type of the variable, which is felt252. Then we have another function called validate deploy. What this does is, whatever through this account, if you're trying to deploy another new smart contract, then you will call this particular function to validate that that particular deployment is correct. This is an external function. That means it can be called externally. And then we have a function called validate declare. So whenever you are deploying a smart contract on Starknet, you have to do that in two steps. First is you have to declare that particular compiled smart contract. And after declaration, you will get something called as a class hash. And once you get a class hash, you have to use that class hash and then deploy the smart contract. So these two functions are actually very validating the declare transaction and the deployment transaction. There is a general validate transaction, which is just going to validate any type of transaction. And then last but not the least, we have the execute transaction, which will execute a particular transaction that will come to this function. So these are the base functions that are present in an account abstraction contract, right? And then from here, you can see a couple of different things. How do you return a variable? You can use an arrow. You have to separate the return variable and the argument list by an arrow. And then you can have different types of arguments. Like here, contract address is one type of argument. Then felt252 is the entry point selector, which tells us which function needs to be called, for example. And then there is call data that you can send in the form of arrays. So arrays are also supported. This is a particular array of type felt252. But you can also have different other data types that are supported, which is uint, then u256, u32, etc. Right? Now that we have a basic understanding of what are the functions that are supported in account abstraction, let's get started with writing our own contract, which is an account abstraction contract, which supports multi-calls natively, right? So if you copy pasted this program from this gist, you will have this entire piece of code where you can find a lot of TBDs that is to be done. And these TBDs are pieces of code that we will write together. And full credit to Darlington again, who has created this multi-call contract. and he works as a DevRel with Argent. So full credits to him for doing this. And as the Cairo 1 syntax has undergone some recent changes, you can also see that if there are some pieces missing, that can be taken care of. So let's start coding. Is this font good enough for people? Are you able to see that what is there on my screen? Okay, let me see. Yes. Okay, perfect. So let's get going. And I would like everyone to sort of, code with me, because even if you're not able to build at the end, it is fine. Right now, you have the opportunity to write. So think of it as just as a, notebook or notepad where you're just writing some lines of code. Writing code is always going to help you, feel good about yourself, but also get more into the code aspects of the programming language itself. How do you actually write stuff practically? So the first thing that we see here is imports, right? And this import surprisingly is out of the module. So in the previous example, we saw that library imports were within the module. So you can see that that's also the case. But here, these are global imports. That means you can use them throughout different modules that you write. Here, we are only going to focus on one particular module, that is account. And then we have again a global structure that we have defined, which is called as call. So the keyword to define a structure is struct, followed by the name of the structure, which is call. So this particular structure tells us that in a call that will come to this account, what are the different things that will be a part of the call. So it will be a to address to which you would make this call, a selector, which can be a function selector if you want to execute a particular function, and then the call data that will be part of this call, right? To which contract are you going to be making this call? So it could be a transfer call, for example. It could be invoking a function in a specific contract, etc. So in the transfer call, for example, the contract address, the to address will be the other smart contract account of the person to whom you want to transfer, right? And in the case of actually calling a smart contract, in the case of calling a contract function, then in this case, the contract address will be the address of the contract itself. And then the selector will be the hexadecimal address of the function that you want to call. And then any other call data. For example, if you want to send some arguments, some parameters, etc., that will be wrapped inside the call data. So we have these global structures so that we can use them anywhere within our program, within our Cairo file. And we can start writing our account contract by defining this particular macro, which says account contract. And then we start with the keyword mod, followed by the name of the contract, which is going to be account in this case. And within this particular brace and the last brace, which is the white one, we are going to write the entire logic of what we want to do in this particular contract. This contract looks very big, but it is actually very simple. There are some functions that may look overly complex. You don't have to understand that right away. But as you go through this contract like one after the other, you should be able to, get a hold of that. So the first entire, like the longest part of this entire contract is basically just importing a lot of different things. So from the Starknet library, we want to import several different functionalities, like get the caller address. So this is similar to message.sender, where you want to get the address of the account that has actually called this particular, function or things like that. Then you want to also get the transaction info, that who has signed this transaction, what signature scheme is part of the transaction. So all of that you will get from the transaction info. And then if you want to call, a particular function, then you will have to use the call contract syscall to actually call the particular function, right? If it's a transfer call, if it is calling a function within a contract, etc. And then validator is just it's just like a enum that you can use to say that yeah, this is like 0 or 1 or whatever. And then from the array library, we're going to import the array trait and the span trait. So think of traits as more like interfaces, which tells us what this particular kind of feature should do. What should be the characteristics of this feature? So array trait is basically going to have what are the things that arrays can do, similar to span trait. Span trait also is similar to what are the things that spans can do. Both of these are within the array umbrella, but array traits can be manipulated, extended, etc. Span traits just make a copy of the array and work on that. Similarly, we have box trait. So like I mentioned, Cairo programs compile to Sierra. And one of the features that makes Sierra a safe intermediate representation is that it has interesting cool properties like boxing, not the punch one, but actually using this concept of boxes from mathematics to define variables, to box the variables, to kind of have boundaries around them. So this is a very interesting type of data type that you can read more about. Then we are using one particular type of signature for this example, which is ECDSA. So we're going to import that functionality to check the ECDSA signature. Then a contract address data type, which we already saw. Then we have some other data types that I'm just going to leave it for now, as it's not super important. Okay, so let's get started with coding. The first thing we are supposed to do is to create a variable called public key. Now, whenever you're going to create permanent variables in a Starknet contract, in a Cairo 1 contract, you will need to use the struct called storage. The name of the struct has to be storage, right? That's the only way that that compiler will recognize that this particular variable is a permanent variable, is going to be part of the permanent storage. So we are going to give it as the generic type fel252. So it says create a variable called public key. So we created a struct called storage, and within this we have created a variable public key of type fel252. So this is the name of the variable, colon, type of the variable, and that's it. So we are only expected to create one variable, right? So let's remove this TBD because this is done. Now let's go to the next TBD. So within the constructor, we have taken an argument called underscore public underscore key of type fel252. So here our TBD is to set the public key's value here. Use my English. So how do we write to this particular variable? We can because this is a global variable and this is part of the storage, we can use it anywhere within this module, and it is directly accessible. So we can directly write to this variable by saying public underscore key colon write, and here we can give the new value that this particular variable is supposed to take. That's it. And because we are not returning anything in this function, we can put a semicolon to close this function. So in this constructor, what are we doing? Whenever we are deploying this contract, right? This is an account contract. So we are pre-generating a public key for this account, and we are sending that as part of the constructor, saying that this particular account will now be known by this public key. And we are setting that public key at the global level for this particular account contract. Now, the next functions, you will see most of them are going to be calling the same function. So validate declare. Like I mentioned, this validates an account's declare transaction, right? And then validate deploy. This validates an account deployment transaction. And then just validate. It validates a transaction before execution. Right now, because this is a sample contract, all of them are calling the same function called validate transaction. So let's go to that function. Okay. Validate transaction function is a function that does not take any arguments and returns a felt252. Now let us see what are the TBDs over here. Okay. Okay. Before that, because I have said as above, so let's look at the execute function. So the execute function is simple. It executes the transaction, right? This execute function takes a bunch of calls, right? Remember that this is a multi-call by default, right? So it's multi-call.cairo. That means this supports multiple calls by default. So this takes in as a parameter an array of multiple calls, and then it returns a span, an array of different spans of felt 252. So the first thing that it is asking us to do is check if the caller is a zero address. So how do we get the caller? If you remember, we have imported something called as get caller address, which is a function from the Starknet library. So we retrieve the caller, right? And we can check if the caller is a zero address or not. Okay, so we have to get the caller address. We have done that. And then we can assert if this caller is zero or not. If it is, then we will say that caller can't be zero. Okay. So this particular function is, I mean, these two TBDs are done. So you have gotten the caller address into the caller variable, and we are checking if this caller is zero or not. And if it is zero, then we can throw an error message in the assert. Now here, in the next step, we are going to check if a particular transaction is valid. So how do we check that? We can get the transaction info using this particular function, right? And then we are going to assert whether the version is not equal to zero. If it is equal to zero, then we are sending an error message that it is an invalid transaction version. But to get the transaction info, we need to have get transaction info. And like I said, there is a special variable called box type, and this particular transaction info returns a box type variable. So we need to unbox it. So we will say unbox, and then this particular transaction info will get unboxed into this variable called transaction info, and we can run whatever asserts we want on top of this transaction info. So, and the last but not the least, we are going to call the internal function execute multi-call, right? Which will call all of these, which will send all of these arrays, all of these different calls to this particular function, and it will execute the multi-call. Let us see after this transaction that how this execute multi-call works, right? So this TBD is done. Let's remove it. These two TBDs are done as well. Remove them. As you keep writing the pieces of code with me, please remove the comments. Okay. Okay. Sorry, I thought I got logged off. So now the last function that we are going to write as part of this hands-on live workshop, and then I will also show you some other pieces of code that you can get. So now the validate transaction. So we need to get the transaction info as above. So let's do this and get the transaction info. Once we have the transaction info, we have to get the signature variable from the transaction info. So we can say transaction underscore info dot signature. Okay. Now we have to check. So this is an ECDSA signature. So the ECDSA signature will have two components, R and S, which are integers, and using that and then some time factorization, etc. That's how the ECDSA signature works. So we need to do a simple assert on the signature to make sure that this signature is right, where we are going to say that signature dot length, that is the length of the signature, is equal to 2. Now, this particular signature dot length actually returns the data type U32. So in Cairo, if you want to wrap a particular variable into another data type, or you have to cast a variable into another data type, you write the variable name, or in this case, the value, underscore the data type which you want to cast into. So in this case, I want both of these to be U32, right? So this is already U32. So I'm casting 2 to U32. Why? because 2 by default is actually felt 252. Like I mentioned, the default variable type is felt 252 because field elements are the most popular type, are the most basic type of elements for Cairo as a programming language, right? So we have to typecast this into U32 using this particular format. And then here we can send an error message that signature length not matching. So once we have done all of these asserts, let's remove the TBDs. So we have got the transaction info, we have got the signature from the transaction, and we have also done an assert to check whether the signature is valid or not. Once this signature is valid, then you can use the check ECDSA signature function that we imported from the library, and you can send the message hash, the public key, and the signatures that we just extracted from our signature variable, and you can check the validity of the signature. Okay, I'm just going to copy paste this message here, right? And if it is, if this assert passes, then you can say that yes, this particular transaction has been validated. Now, one small point that I wanted to show here is whenever you want to access the global variables, you have to use the read function. That is : read. And whenever you want to change the global variables, you have to use : rect. That's it. Very simple. Last and the main function here, there are no TBDs, but there is just the function that is execute multi-call, which takes all the calls. And you can see why this is taking a span instead of array, because you don't want the values to be able to manipulate. You don't want anyone to be able to manipulate the values, right? So you take a span instead of an array, and then you return a bunch of spans, an array of span variables. So you see the result, which is you are creating the same result, the same type of variable, and you are creating a mutable variable called calls, which will take this particular calls over here. Now, like I said, because it is multi calls, what we are going to do is we are going to loop through this calls span. We are going to pop the front element. So think of this as like, in stack, you have the topmost, in queue, you pop the front, right? So think of this like a queue. So you pop the frontmost element, the first call, and then we use the option type, right? Option type is used for you to give type safety. It largely comes from Rust. So if there is, for the option type, this call, it can either be null or it can exist, a value can exist. So some refers to a value existing within this call variable. So this call is basically your front, whatever you popped at the front, and then you're gonna match, which is like switch case. So you have the call contract syscall, which has been taken from the Starknet library. You take the two from the call, the selector, and the call data that exists, right? And you match if this is okay, right? Is the to address, the selector, and the call data okay? If it is okay, then you append the return data to the result. If it is error, you revert with the reason saying multi-call failed. So this will keep on going for the loop. And if there is no call, once this is empty, your calls array is empty, you won't get any call within that array, within the span. So when you reach the option none, you break out of the loop and you come out, right? And you return the result, which is an array of span of fetch to 52. So weird to say. So this is a very simple account contract which natively implements multi-calls, right? You can take this and you can use this for your hackathon as is. You can also use variations of this by adding things like multi-sig for yourself. So if you want to understand how multi-sig works, we have the Starknet book where you have different types of examples of contract within the account abstraction. So you can have multi-sig. You can have different types of signature that you want to implement. Here we are implementing ECDSA, but you can implement your own signature as well. There are different types of practical examples. So here is a multi-sig practical example where you have multiple owners, and how do you actually, execute this when there are multiple owners. So you check signatures by everyone, if everyone has actually signed. So you see the number of confirmations and all of that, right? So this is an interesting contract as well that you can work on um, as part of your hackathon. And then, there's just like sky is the limit. If you're interested to explore more, we have some chapters in our Staffnet book that you can also contribute to by writing your own contracts, like alternative signature schemes, auto payment accounts, and things like that. So you can write your own contract and you can also contribute to this. And that can also be part of your hackathon project for you, right? Yeah, and this is a very simple account contract. Hope you were all able to sort of uh, work with this. And to compile or to build, you can just use, like I mentioned, and like we did it with our previous, what is this, workshop folder as well. You can just use you can just say scar build. And once you do scar build, you should see, and don't forget to add your where is this, Scabra.toml. Don't forget to add this in the dependencies, so you can actually compile your contract, you can build your contract. And then if you want to deploy your contract, then you will have to do some more tooling, because carb only allows you to build the contract, which is easy for from a workshop model. But if you actually want to deploy the contract, then you have to go to getting started, and then you can set up your environment, and you can use these instructions to deploy your smart contract. So creating a new account, funding it, and then doing all of those things takes a while. So I didn't do it in the workshop live, because we'll have to wait for the transaction to go through, etc. But you can do this in your own time. And if you have any questions, feel free to reach out to us, and I'm happy to help you, with your environment setup or anything where you are getting stuck. Once you set up your environment, you can, once you have built your contract, you should be easily able to declare and deploy your contract. So, and last but not the least, I have some resources for you on Starknet book, Cairo book. So Starknet book is what I showed you just now. It has all things Starknet, code examples, then account abstraction chapter, and all of these different cool things. Then Cairo book is all about Cairo. It is a community contribution. Both of these are community contributions. So if you want to also contribute, you can to the Starknet book or the Cairo book, and you will find a lot of different Cairo syntactical things in the Cairo book. So it's also very interesting. And yeah, last but not the least, huge credit to my colleague Yael, who prepped this whole series of slides and kind of, let me just have it for the day for the workshop. And here's my Twitter. If you have any questions, you can. I use the same handle for Telegram as well. So if you have any questions, feel free to ping me, and I'm happy to support you in your hackathon project.
Yeah, here Dave has an interesting question as well. He's asking in the chat, why the assertion to check that the signature len equal to?
Yeah. So assertion is basically we want to check whether the signature has the right components or not. So because both of these are integers, like you saw that, let me share my screen again. How do I? Sorry. So when you saw that we need to check the ECDSA signature. So at that time we need to access the zeroth and the first element of the array. So and we need those form the R and S components of the signature, right? You can read more about the R and S components of an ECDSA signature, but this is a simple assert check to make sure that the signature is not invalid. So if this is a valid signature, it will have an R component in the zeroth place. It will have an S component in the first place. You can also assert it as something else, but this is the you can also assert other things. For example, you can also assert that both of these elements are non-zero, etc. But this is a very simple assert that would work for a simple contract. Like you're just checking the signature length, and if it is two, exactly two, then it is the kind of signature that you're looking for, which is an ECDSA signature with RNS components. Was I clear? Was that understandable?
On my end it was, but
Dav?
maybe Dav can respond in the chat if it helped.